Now that we've learned the electron diagram, we can start to do the electron notation. We've learned all the rules of why the electrons fall into certain orbitals at certain times, what all of them are and what they hold. And so let's learn one more called the Madelung rule. And it basically is where we can do a diagonal rule when we write things out. So go ahead and list all of your energy levels 1, 2, 3, 4, 5, 6, and 7. All of them are going to have an S. Then starting at 2, you're going to add P's for every one of them. Then at the third energy level, you add D's for all of them. At the fourth energy level, you add F's for all of them. So you can see you add a different sub-level each energy level you go down, right? But when it comes to putting electrons, you diagonally slash through these so that you know which one to go in first. So after you end at the arrow on one, you go back to the tail on the other and start down. So we go through and add electrons to 1s, followed by 2s, followed by 2p, then 3s, then 3p, into 4s, then 3d, into 4p, to 5s, and so on and so forth. If you want to see, I listed a lot of them out up here. We also need to remember about putting electrons in, because these are the sub-levels that we're putting stuff in the order that we're going to put them in, but we need to know how many electrons we can put in each. So you need to remember that in every sub-level, you have a certain amount of orbitals or configurations. So in S, it has 1 configuration, meaning you can get a maximum of 2 in any of these S's. In the P, it has 3 configurations of its orbitals, and so you can get a maximum of 6. So 6 is the max in there. For D, we're only going to be able to get 10 in there and 14 in F. So they kind of increase in the amount of electrons you can put. This is important to remember because if you remembered last time I showed you this slide and I said this was for oxygen, and notice that it has something that was missing a minute ago. So this is its energy level, this is the sub-level, but this is how many electrons it actually has when you're listing it through. So with oxygen, we know that this P level can hold up to 6, but it only had enough electrons to fill it to 4. And so that tells us that we're looking at oxygen in a ground state and neutral atom, okay? So essentially, you're just changing the superscript, that's what you call it when the number's up at top like that, for how many electrons are in it, even if you're in the same orbital. Because no, in 1s, we have both hydrogen and helium. Well, hydrogen is designated with 1s to 1 superscript. And then helium is going to have an extra electron, so it's 1s2 in the superscript. And that's how you can distinguish between the two, even in the same sublevel. Now let's try working some out that are a little more difficult. So 2 things I'm going to want whenever I'm writing the shorthand. One is my periodic table, so I can see where things are located and what electrons I'm going to need. Secondly, I'm going to go ahead and draw this out for myself on my paper so I know what order to put them in as I write them in this notation. So let's look at one that's a little bit more difficult than what we've looked at before. So let's look at 10 right here. Sn is 10, has 50 protons, meaning we're going to make it with 50 electrons. So first thing you're going to do is you're going to write out your symbol that you have on the periodic table there. So I know this is Sn, okay? That's for 10. And then we need to write our notation of its electron configuration. So what you need to notice is where it's located. This, if you remember, or these right here are s orbitals, right? With the exception of helium that's also in the s orbital. These are our p orbitals. This is the d orbitals, and this is the f orbitals. Because of that, I can see that 10 is located in the p orbitals on the 5th row, 5th period, right? So that means I need to start following my trends here until I get all the way down to 5p, okay? So I know that 5p is going to be where I'm looking for something. So I'm going to even go ahead and mark that 5p. That's where I'm going to want them. All right. And then I just start going down my list and writing these in for every one that I have. Remember, you go diagonally down, then you start at the top of the next one, and you keep going, and you just write each of them. And so it's simple enough. We're going to start with our 1s, then our 2s, then our 2p, then we have our 3s, and see how I'm just going down, 1s, 2s, 2p, 3s, next is going to be 3p followed by 4s. So we have 3p, 4s, 3d, 4p, 5s, 4d, and then 5p. All right, so this is all of the different sublevels that I'm going to be using. Now I just have to fill up the electrons. And I have 50 some to fill up because we said it's going to be equal to the amount of protons because it's a neutral atom and it has 50 protons. So we just start to add the number depending on what it is. I'm going to write it in red so we can see it a little easier, but it should work just as well. Okay, so remember my S sublevel can only have 2. So I'm going to go ahead and write 2, 2, P is going to have 6, then 2, 6, 2. Our D can have up to 10, so I'm going to put 10 there. P, 6. Then 5S can only have 2. D, 10 again. And then I'm going to hold off on that last one, because let's go ahead and add them all together to see how many we have so far. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, 18, 20, 30, 36, that's a terrible 2, but 38, 48. So that means we only have 2 left to go in this p orbital. So even though it can hold 6, we're going to put that there are only 2 in there. So we're just going to put that superscript of 2 there. And yes, I'm going to go back and erase this so we can actually tell that that is a 2. Sorry about that, guys. All right. So this actually is the electron configuration of 10. All of this together. But it tells us exactly what electrons it has in what sublevels and what orbitals, because we can see that it's completely filled. And that is how we do the electron configuration notation.